So the average rate of change, connection to difference quotient. Any questions so far? Let's stop for a moment. Let's see if you have any questions. Anyone, any doubts? Okay. I'm going to copy the same picture. We have the same function to look at. And this is our f of x. But this time, we have a point here. Let's call it P of coordinates x and f of x. And I have another point that is right here, very, very close to P, very close, not the same point, very, very close. But allow me to zoom in so I can explain. If I show you a point here and a point here, I can't explain anything. You're not gonna see anything. So allow me now to zoom in, but they're very, very close to each other. So I'm zooming in, and this is my point Q. But it's so close to P that his x coordinate is x plus a little bit, tiny. X plus tiny, x plus a little bit. Can anyone give us the y coordinate of Q? Remember, Q is right here. Very, very close. We're zooming in. Can anyone give us the y coordinate of Q? We know P, x, f of x. We know Q, x plus h.
F of x plus h.
Brilliant. Thank you, Kevin. Imagine again the secant line passing through these two, and I want to determine the slope again, but this time just for differentiating from the previous one, we called it PQ. Can anyone give us the slope of this line? And then we'll identify and we talk for a minute about what it means. Because this one we know what it means. Oops. That's not the page I wanted. You know what this means? It's the average rate of change. I drive to New York. It took me 7 hours, 200 miles. It was a very slow ride. 200 divided by 7 hours. And I tell you the average rate. So now, how do I write the slope of PQ? Just the notation is different, nothing else is different. Anyone, please? It's nothing different.
Is it f of x plus h minus f of x? Over h?
True. Over x plus h minus x, which simplifies. So this is what it's called the difference quotient, which is f of x plus h minus f of x divided by h. What does it mean? Again, this is the slope of the secant line. This is still the slope of a secant line, but the points are very, very close. And it's almost, not quite, almost the slope of the tangent line, which is not the average rate of change. You'll see in the next class. It's the instantaneous, but it's almost, it's not exactly. So because the points are so close to each other, this is still a rate of change, but it's almost, not quite, the instantaneous rate of change. Almost, not quite, the slope of the tangent line at this point. Okay? In this class, we are concerned with finding and simplifying the difference quotient for several functions. So let's open up the handout, and let's choose which functions you would like to work with. Quadratic, rational, radical, pretty much. So the handout is posted. I'm getting to it right this moment. Difference quotient. So let's choose whatever you would like to start with. So the question is asking us to find and fully simplify the difference quotient for these functions. What will I find? An expression that eventually in the next class will give us the slope of the tangent line to the graph of the function, or the instantaneous rate of change. Okay, quadratic, rational, radical. Or you can make one up. Make one up yourselves. A quadratic, a rational, a radical. Make up any function so we can analyze, simplify, and determine the simplified form of the difference quotient for any function you would like to pick. Quadratic, rational, radical. Let's choose. Please. Anyone? I see a chat. Yes. Okay, so 86. Perfect. So we want to start with 1 over x plus 3. Perfect. 1 over x plus 3. This is our f of x. Perfect. Okay. Good pick. And then I would like you to make up a quadratic function, any quadratic function, so we can work on that. Okay. So the difference quotient, moving forward, we have to remember f of x plus h minus f of x divided by h. Now, for this function or for any function, this is very clear. It's given to us. This is that tiny little thing. We cannot simplify, we cannot do anything to it. This is the only portion that we have to worry about or be careful about. Can anyone tell us how to determine f of x plus h for this function? And before you say anything, our function f of x equals 1 over x plus 3. If you give me this function and you ask me, what do you see? Okay, this is what I see. I'll tell you this. I see this. What does it mean? Well, this is the pattern. F of whatever equals 1 over whatever plus 3, where this and this are the same. So if you ask me evaluate at 5, I will say 1 over 5 plus 3. If you say evaluate at 15, I will say 1 over 15 plus 3. If you say evaluate at negative 3, I'll say, oops, I cannot. But now I'm asking you to find f of x plus h. How will you find f of x plus h for this function? And from here, we're going to jump over here. Can anyone give us f of x plus h? Please.
1 over x plus 3 plus h.
Yes, but we are replacing this first. I'm not saying it's wrong. I just wanted everyone to see what we did. Does everyone agree? Is there a yes? Is there a no?
Looks good to me.
Okay, perfect. Anyone else? Okay, Jalen, I know. Thank you. Anyone else? Don't be shy.
Is h just supposed to be whatever goes in the denominator, or can it just be?
So let's look at the pattern. If I want 10 here, I will put 10 here. If I want the x plus h here, I have to put x plus h here.
Oh, okay. That
So
makes sense.
f of whatever is 1 over whatever plus 3. And now you tell me what whatever you wanted it to be, and I have to put it in. Everywhere where whatever shows up. So this is it. Better?
Yeah.
Perfect. What do we need to determine next?
The common denominator.
Thank you very much. Thank you, Axel. Good. So let's find the LCD. Excellent. Well done. Can anyone give us the LCD?
X plus H plus 3.
I would be in big trouble. It's like saying 1/2 plus 1/3 has the least common denominator 3.
Is it x squared plus 3x plus hx plus 3h plus 3x plus 9?
Good, excellent. Note, never multiply factors in the denominator. Okay, let's try again. We have 1 over x plus h plus 3 and 1 over x plus 3. And the LCD will be
Would it just be h? Or am I tripping?
we are focusing on the numerator. In the numerator, we have a difference of 2 fractions.
X plus h plus 3 times x plus 3.
Yay! We are saved. We've done this before. This is not the first time. We had a lot of examples last time. Excellent. This is it. Because the least common denominator of 1/2 plus or minus, doesn't matter, 1/3 is 6. If you remember, we said these two are 2 different factors. They have nothing in common. There is nothing, no factor in common of these two. They're carved in stone. The least common denominator must be the product of the 2. Awesome. Thank you. Who saved us? Who was that?
That was me. I gave you the expanded form the first time.
Yes, we never, I know. We never multiply factors in the denominator. Please don't. Excellent. Good. We would have spent the night here. No, I'm kidding. Okay, so adjustments. What are the adjustments for the top of this and the top of that? What does this one need? X plus h plus 3 was multiplied by?
X plus 3.
Good. And x plus 3 was multiplied by?
X plus h plus 3.
Can anyone give us the top here? What should I write? Please, anyone? Zach and Kevin, are you with us?
X plus 3 minus
x plus h plus 3
We cannot pick and choose.
minus h minus 3.
Excellent. Great job. Okay, this is not done. We have two notes here to write. Note number 1. All terms without h. Maybe some of them with h, but definitely all terms without h in the numerator must go away. If they don't, we'll say, oops, something is terribly wrong. That's note number 1. At this point, I'm going to use a triangle now. At this point, if terms at in the numerator that do not have h, if they do not go away, we have to say oops and start from scratch. Is there anything that I can simplify here?
Can't x go away and 3?
Good. So note number 1 happened. Now we have note number 2. And the notes are exactly in that order. You cannot reverse the order. Note number 1, all terms without h in the numerator must go away. Note number 2, h from the denominator must go away. I'm not saying that the final expression does not have h in it. No. I'm only saying that h in the denominator must go away, and this has to be the second note. After this is completed, this has to happen. Okay, I'll jump over the whole thing to the triangle, and the numerator is negative h. The denominator stays. Do not multiply the factors in the denominator, please. And what do I have to do with h over 1? Because I'm dividing now. This is the division fraction. I have a fraction divided by another fraction. So what do I do now?
Multiply them together? Or put them both in the denominator? Or, yeah, whatever.
So I have a fraction at the top, and I divide by the fraction in the denominator. I copied the fraction from the top. Now times.
1 over h.
Thank you. Note number 2 has to happen. And it does. So the simplified form of this difference quotient for this particular function, see, it still has h in it, but not this one. This is it. And again, if you say, what is this? It's an expression that eventually will give us, in the next class, the eventually, not right now, eventually will give us the slope of the tangent line at that point, or the instantaneous velocity at that point. Not in this class. Something else has to be added in front of it. Any questions on the steps of finding the difference quotient? A lot of work, right? We stated the definition. We identified f of x plus h. We found the least common denominator. We combined like terms at the top. All terms without h in the numerator must go away no matter what function you're looking at. Also, note number 2, h in the denominator must go away no matter what you're doing, what function you're looking at. The final simplified form is this. It's an expression, it's a function, eventually will give us a specific function that gives us the slope, yada yada. Okay, let's make up a quadratic function now. Please, give me any quadratic function so we can do the same thing. I'm sure you remember this from a previous class, but just give me any quadratic function, or if you want a radical function, make up a radical function, up to you. Please make up any. Anyone? Anyone, please? Can anyone make a quadratic function? Make up a quadratic function for us.